We're now about to go back to back with our next segment of the program. In fact, our next speaker is the head of gaming APAC for Google Cloud. He's a national award-winning film producer, Forbes 30 under 30 in 2017, and holder of 3 US technology patents. We're truly delighted to have with us Mr. Sameer Pitalwalla, head of gaming industry sales APAC Google, and he'll be sharing his thoughts on exploring possibilities of AI and gaming. So, ladies and gentlemen, we're talking about exploring possibilities. Let's have a huge round of applause. Please help me welcome on stage none other than Sameer Pitalwalla.
Thank you. Hi, and thank you for being here. Great to see a full house over here. I think before I just start messing up my slides, I'll probably try to go back. Actually, the back cue is not working. Could you? Yeah, great. Thanks. So, the view today was really about what can we look at when two sort of core foundational building blocks that are really exciting in this day and age, which is one is what's happening with games and the other what's happening with AI. And if you actually, Google's had a long history with using both games to train AI and now using AI to transform games. The idea really would be with this presentation to give you a glimpse on sort of what that thinking is and what one can do with it. So, Demis, who just, as of last week, I guess, won the Nobel Prize, has a really good view on, he kind of looks at games as a gateway to AI. He started his career as a computer game designer. He's also a chess grandmaster. So he does have like a good insight on how he has kind of used games to think about AI in general. And, this kind of makes sense if you look at games as a subset of simulation. So it becomes easier to think of, of games as a microcosm of reality to train AI. And Google has a long history of doing this, starting with deep Q networks, which it used to train AI agents to play Atari games at a human-level performance. This was in about 2015. And this was revolutionary at its time because it was the first time that something just looked at pixels on a screen and learned how to develop really interesting strategies to end up winning those games on Atari. The next one was AlphaGo, and this was sort of a big breakthrough. And I think Harsh spoke about this in his presentation about how AI and games are linked up. And the reason this was super interesting and more so right now is because this was really the advent of what you call as now thinking machines. So you'll hear a lot more about this in the days to come, where these AI systems are stopping and thinking before making their next steps. If you read Daniel Kahneman and thinking fast and thinking slow, this is what you call as type 2 thinking, where it's not just on the back of the data that it's trained on, but it's on a whole new scaling law called test time. So it actually, if you think of AlphaGo, it's one of the most complex games ever created. There are more possible moves in Go than there are atoms in the universe. So every time the AI had to predict what its next move was, it actually had to sit back, think about all the potential outcomes, what its next move could do, weigh them, and then actually play that. So this was sort of a revolution in terms of how AI systems were thinking before making the next move as well. This was followed by AlphaStar, which was the first AI to reach the top league of a widely popular esport without any sort of game restrictions. A preliminary version of AlphaStar challenged 2 of the top players in StarCraft. One of the most popular enduring games. If you know Korea well, they actually have a national StarCraft day, where it's a public holiday where everybody can actually just sit back and play StarCraft. So it was a really big deal at its time. And what happened was that it was not only able to kind of perform at a high level, but it actually was anointed a grandmaster state, which means that it was able to play the game at the highest quality possible and simultaneously, defeat a lot of folks who are really good at the game. We have made a lot of progress since then. So in 2024 alone, this year, there have been 3 major announcements. So with deep tie-ins to the potential future of games. Starting with Genie, where you can generate a playable 2D side scroller with simple text commands, right? Every frame that's generated is dreamed up in real time by the model. So this is not using a game engine like Unity or Unreal. It literally predicts the next frame depending on whether you're going forward or upwards. Think of you playing a game like Dangerous Dave or Super Mario, except that the next step is predicted by the machine and actually generates it in real time. Game Engine is the one which actually released just a couple of months ago. It's similar to Genie, but it was trained on Doom. So think of the previous one being a 2D side scroller. This one is actually kind of using the formative 3D game, which is Doom. And it's the first kind of video game, the pun is intended, because it generates, again, new frames without the aid of a real-time game engine. So it's literally generating video frames depending on the kind of action you're doing, except in 3D. And finally, SEMA, which is where agents can autonomously figure out in-game tasks. So this is interesting because we actually did across a variety of games. So there was No Man's Sky, there's another goat simulator. All you have to do is put in a command where you tell the agent, reach the end of the level while staying alive, or simple things like go collect resources, enough resources to go build a base. And it was able to do this inside of the game world without any other further instructions. And at Google, these efforts are built on years of groundbreaking work in AI. So right from the invention of transformers to industry-leading models such as Gemini with a 2 million long token context window as well as native multimodal understanding. So these are all building blocks which take us to sort of like an exciting new era where we believe that games are also, just like they are a gateway of AI, to AI, we think AI is going to transform the way games are made. At the heart of this transformation are how games are maturing into platforms enabled by UGC. So you're seeing games like Roblox, Minecraft, and Fortnite beginning to do this with enabling user-generated content inside of them. And the three defining characteristics of how developers can build larger games are that developers can build larger games faster, with smaller teams, and most importantly, a whole new set of game mechanics and features. So the way we play games, the way we actually experience them will be redefined because the core primitives that one is using to build them allow you to do something really cool. You can actually build these sort of emergent systems and emergent mechanics that create a whole new set of experiences which weren't possible before. And this is impacting the whole value chain. So right from pre-production, you're seeing smaller teams being able to attempt larger capabilities in terms of AAA production by reducing cost, right from the ability to generate new assets to generating environments, being able to retexture them really quickly. So you're seeing a whole example of AI transforming the entire value chain. And this is now, if you look at the building blocks, you obviously start with 2D, right? And Google's done some incredible work in building these foundational models across images, video, and I'm going to walk you through some of them, and then we're going to build up to what one could do with it. So let's start with Imagine 3, right? It's a best-in-class image generation model. It can create stunning images across a variety of domains. We're building on taking these single frames and making them into 25 frames per second, which is really what you need for video. And that's where Veo is our video model, which does, again, you're seeing some parts of this now coming up in YouTube, which has recently been announced by YouTube, where creators across all scales and sizes can use some of the faster versions of Veo in creating videos inside of YouTube. Music LM allows you to now build the third building block, which is generative audio. You want royalty-free music. You want it married and paired with the tone of your game. You even want it tuned to the particular portion of gameplay. If you're going in for a typically really adrenaline-pushing, heavy, adventurous section of the game, it can actually adapt by looking at the context of the game and begin to actually compose that audio in real time. So it also means you can compose this audio in terms of personalization depending on what the user likes. And finally, generative 3D assets. This is sort of like the holy grail when it comes to not just creating 3D assets that can dress a game up, but then can also be readable inside of a game engine when it comes to the meshes being something that you can manipulate. This is, by the way, already in production, so a lot of what you will see in terms of when you search for shopping on Google and you see those 3D assets, it's being built out of this model. All you have to feed it is 2D images, and it kind of makes you think that if you can create synthetic or artificial images via Imagine, you can even create artificial 3D objects because you have the building blocks of 2D to go to 3D. So how might you use all of these tools in games? And let's start with defining an art style, right? So the first thing which you want to do when you're trying to figure out a game is, what can you do to actually define sort of in this case, a pixel sort of art style? You create a prompt, you define it. After that, you can pretty much take anything. You can, think about enabling user-generated content. You get a user to take an image of themselves eating, in this case, a hot dog, and then you can transform that image into something that's consistent with the design and the art theme of your game. Now you want to find making easier. You don't want people sitting around doing prompts, and this is where you can actually, this is sort of the new age of what UI and UX will look like, which is promptless prompting. So think of it as a mood board, which allows you to just use simple gestures and touch to be able to create new images and get yourself from the real world into the game world, and with the same sort of art style and theme. You can do pretty cool things with this promptless prompting framework. You could, just literally draw an illustration. And once you draw the illustration, you take an existing image in that art style, marry it together, and suddenly you have the same form and the factor, which is still there. And then after that, you can scale it infinitely. You can pick any image from any part of the world, and all now can come into your game world, and you won't have to break a sweat. Nor your users will. And why stop at just character art assets when you can take environments? You can take this room, take a picture, and now suddenly you can have the whole environmental asset as well inside of that game world with the same design consistency. Add some royalty-free music using one of our tools, and now you have a simple 2D side scroller. It's sprite-based, but, well, you can't ask for too much right now. But you can actually build an entire 2D side scroller right now using the building blocks that we just showed you with Imagine audio, as well as some of our 3D art generation assets. And we believe that this is going to kind of enable the next 1 billion game experiences, because these will be infinitely adaptable, they'll be super personalized, and you can do them at scale. Now, obviously, to do something like this, you need a truckload of capabilities when it comes to AI, but also in terms of infrastructure. And Google's uniquely positioned with cloud to be deeply vertically integrated. It has both a consumer business and surfaces across a variety of products like YouTube, Play, etc. But it also has its own in-house research team. So the models which you see here are ones which we actually build out ourselves with, obviously, DeepMind being our research lab along with Google Brain. But you also get access to some of the world's best models, whether it's Meta, Anthropic, on Vertex. So you're actually able to not just limit yourselves to Google's first-party models, but on the same infrastructure, use any of these other models. And it has vertically integrated its way all the way to the chip layer with TPUs. So these factors actually offer you really long-term structural advantages. And to orchestrate these real-time Gen AI-enabled games, you need low latency. So you can't always hope that you're going to be able to do this on the cloud. You need it at the device level. And that's where you need both cutting-edge cloud capabilities, but also on-device AI. And that's where I think what we're doing on Pixel and Android is pretty incredible. With Gemini Nano, many of these incredible innovations are available at ultra-low latency and at cost on Android devices, allowing you to create these unique experiences faster, privately, and at low cost. For years, we at Google Cloud believed that live services games were the future. Games as a service is the dominant business model currently in the world. 95% of all the games in terms of revenue are all games which are essentially free to play, and they're offered as a service which you can, buy in-app purchases with, or watch advertising to subsidize your time. And now that we are here, we look at what's next, and we believe that living games, which are where there's a whole new category where developers and players constantly interact with these game worlds and are co-creating these worlds and are building these large immersive worlds with a whole new economy. And we believe that's really the future, which AI will enable, allowing anybody, just like what happened with video, to be a creator and be a participant in this huge $220 billion economy globally. With that, thank you for your time.